8 wells feed a single giant structure, yet the Troll A platform handles added gas flow through a compact processing module without expanding its footprint. Installation focuses on integrating new capacity into existing systems while maintaining stable operation. A 36-inch pipeline links subsea templates to the platform, carrying large gas volumes across the seabed. That pipeline diameter alone signals how much material moves through this system. Subsea structures are positioned first, creating connection points for wells and flow lines. Drilling operations complete the wells, which are then tied back through spools and valves. Oh, seeing multiple wells connect into one network really shifts how scale is understood here. The pipeline is pulled into place and aligned with entry points prepared in advance. A processing module measuring about 40 meters in length is lifted and installed onto the Troll A platform. Equipment inside manages separation and flow control under high throughput conditions. Module integration allows added production without rebuilding the entire structure. Power is supplied through existing infrastructure, reducing additional energy requirements. Gas moves from seabed to platform, then into transport networks connected to wider distribution routes. Emissions remain low, around 0.1 kilograms per barrel equivalent. That combination of output and efficiency feels almost unreal at this scale. The system extends operational life beyond 2050, supporting continued extraction from the field. Road surfaces regain structure without adding new material. The HBM grader with steer ripper and plate compactor reshapes existing forest roads into functional profiles again. This HBM grader system handles forest road maintenance by loosening, mixing, reshaping, and compacting the original surface layer. The grader carries a hydraulic ripper mounted near the blade, while a steer plate compactor is attached at the rear. Material from the road edges is pushed back toward the driving surface after clearing side buildup. Oh, the road doesn't get replaced, it gets rebuilt from what's already there. The ripper breaks up ruts and potholes to the required depth, allowing the material to loosen and blend evenly. This mixing stage redistributes aggregates across the surface. The grader blade then shifts the material toward the center, forming a raised profile that directs water outward. Whoa, that center ridge quietly sets up drainage without extra layers. Compaction follows, using the rear-mounted plate compactor, pressing the surface into a stable form. Edge areas near the ditch are compacted as well, ensuring water can flow away from the road. The system performs multiple tasks in one pass, reducing the need for added materials while restoring road usability. Road construction unfolds through planning, funding, site preparation, and building, with teams coordinating surveys, utility relocation, and phased work to shape durable traffic routes. The terrain appears too unstable to work on, but the excavator maintains balance and continues digging. The all-terrain excavator operates on uneven, hazardous surfaces to remove soil, clear obstacles, and reshape land safely. The machine adjusts its stance to maintain balance. Hydraulic arms extend to reach difficult sections, cutting into compacted soil or debris. Hydraulic pressure changes continuously to match resistance from compacted layers. That reach allows work to continue without repositioning every few seconds. Material is lifted and moved aside, opening space for further excavation. Bucket movement alternates between digging and clearing, maintaining steady progress across challenging terrain. Operators guide each motion to avoid instability while still removing large volumes. Each bucket cycle clears a wider working zone for the next pass. The machine handles uneven ground without slowing the overall pace. Operator input adjusts arm reach to avoid collapse zones. As excavation continues, the terrain is gradually leveled or reshaped according to the required layout. Loose material is redistributed or removed to stabilize the surface. Final passes refine the area, ensuring access for further work or construction tasks. Surface grading continues until drainage paths reconnect across the full area. Final shaping leaves a continuous working corridor for follow-up operations. Follow the grading steps to see how a slope becomes a structured roadway base. A motor grader system shapes uneven ground into a controlled road surface using a Caterpillar 120K grading machine, working across embankment material to prepare fill and final leveling for pavement structure. The operator guides the machine along a sloped bank, pulling soil downward in controlled passes. Blade angle is adjusted to cut into compacted earth, breaking high spots and redistributing material across the working lane. Each movement shifts soil toward low sections to build a consistent elevation profile. Hydraulic controls refine blade height and tilt during travel, maintaining continuous contact with the surface. Soil response changes with pressure, sometimes rolling forward in loose waves before settling into position. The machine drags terrain into order like it is rewriting the ground line by line. Material removed from the slope is reused as fill for roadway formation. Feels like the surface keeps getting redrawn every pass. Final grading smooths irregular sections into a uniform base ready for compaction and paving. A heavy steel ram is lifted high by a mast system, then released to fall freely onto a parked vehicle. The impact structure crushes the car roof and frame under vertical force. Each drop compresses metal further, deforming panels into flattened layers for scrap handling. The mast resets after every fall, preparing another drop cycle for progressive destruction and material reduction before recycling transport. A 25-meter tug vessel is assembled in a shipyard where large steel blocks are lifted and aligned along a fixed keel structure. Cranes move between sections, lowering prefabricated modules into position before temporary supports stabilize the frame for welding. Hull plates and structural sections are gradually joined, forming the base shape of the vessel. Welding teams secure the connections across hull seams and internal reinforcements. A suspended steel module hanging in the air suddenly feels heavier when it pauses before placement. Hydraulic supports keep the structure steady, while continuous weld lines lock the framework into a unified body. As more side panels and deck sections are installed, the outer hull gradually closes into its full form. A steel block sliding into position looks like it should miss alignment, but it settles exactly into place. Inside the hull, bulkheads and internal frames divide compartments and strengthen the vessel against marine stress. Wiring paths and service routes are integrated into the structure. Deck foundations are installed, followed by protective coating to resist seawater exposure. A lifted section shifting into place creates a brief imbalance before everything locks together structurally. Final inspection confirms structural integrity before the vessel is prepared for launch and outfitting. A machine focusing only on the roadside shoulder reshapes the edge without altering the main driving surface. The road shoulder cutting machine moves along an aging roadside edge, removing accumulated material while shaping a clean boundary between pavement and soil. The cutting unit engages the shoulder surface in a steady pass, guiding debris outward as the machine advances. Height and angle controls adjust to match surface resistance, keeping the removal depth consistent. Material flow stays continuous beside the machine path. A tracked storage handling unit moves along guided rails and reorganizes container positions across multiple shelf levels. The unit travels upward along fixed rails, aligning its clamp system with a selected container, then secures and removes it from the shelf for transport across the storage area. The system raises again toward the rack level. Once aligned with a target slot, the arm pushes the container inward until it locks into place on the rack. The cycle repeats across different levels, reorganizing storage layout step by step. A single lift action connects floor movement and upper rack placement in a continuous handling loop that feels tightly coordinated in execution. Containers shift through repeated transfers without breaking the flow of movement between levels. Each return path resets the arm for the next pick point while maintaining consistent positioning accuracy across the whale system. What happens when a fully built ship enters a recycling process that removes equipment, empties systems, and cuts the hull into sections? Internal systems are cleared first, with machinery and components removed for storage and reuse. Fuel tanks and storage spaces are emptied and cleaned to avoid residue during later cutting operations. Cutting equipment now engages the hull, dividing steel sections into structural parts so large panels can be handled without excessive stress and into layered material segments. Recovered parts are sorted and moved into reusable and recyclable groups, keeping usable systems intact for future application. Steel sections are lifted away using handling systems, and moved through processing areas for further refinement. There is a clear transition, a complete vessel turning into organized streams of separated material. The sequence continues until the entire hull is clean, leaving only categorized outputs ready for recycling workflows. Load track ballast into Ballast Cleaner 001, and it travels through layered separation paths for cleaning. The machine feeds mixed track stone into a vibrating screening section where finer waste drops away while usable rock is kept moving forward. Conveyor paths split the material into different streams, sending cleaned ballast back to the trackside and directing waste into a separate discharge line. Internal screens continue cycling material, so buildup does not block the flow path. Unexpected how much trapped soil gets pulled out in a single pass. The separated stone returns with a more uniform size distribution, while leftover debris exits through the disposal channel. A steady feed rate keeps the system from pausing between loads, allowing continuous processing across incoming sections. A single excavator arm inside Goliath can redraw seabed contours that normally require multiple coordinated machines. Excavation pressure shifts instantly once the arm enters compacted layers. The backhoe arm drops into the underwater layer, grabs compacted seabed material, then swings it outward before releasing it into a transport zone for removal. Sediment breaks apart in uneven chunks before it settles into the bucket. Each cycle repeats along marked sections, gradually reshaping the underwater terrain for port access and depth control. Each repeated path leaves a slightly altered seabed line behind it. Hydraulic joints handle the heavy resistance of wet sediment, while the bucket maintains grip during lift and rotation. Water resistance increases sharply during deeper bucket lifts. No one expects a single arm to keep pulling that kind of underwater mass without hesitation and movement. The arm keeps moving, even when resistance builds across dense zones. Material consistency changes quickly once excavation starts across adjacent zones. Adjacent sections begin reacting differently once material is removed nearby. A second bucket pass follows to refine uneven sections left behind by earlier cycles. Surface irregularities become more visible after each refining pass. A moment like this makes the whole seabed feel like soft clay under extreme pressure. Sediment transfer continues as the dredger repositions along the working corridor, keeping excavation aligned with depth targets. Transport channels remain active while excavation shifts to new points. Removed material is transported away through connected handling systems, clearing space for vessel movement. Each swing of the arm covers a limited radius before resetting for the next dig point, ensuring full coverage of the working area. The seabed gradually shifts profile as layers are removed in sequence. A multifunction surface machine clears soil, fills base material, and installs reinforcement blocks in a single workflow. The machine travels along the work lane, while a front attachment clears excess soil sideways into a controlled line, creating a prepared trench for reinforcement layers. Material is then introduced into the formed channel using a hopper or transport delivery, forming a stable base for placement. A mechanical clamp system lifts multiple grid blocks in one grip, then distributes them in different placement patterns depending on lane direction and layout requirements. The shift from carrying multiple units to placing them in split sequences changes the entire flow of installation without stopping the forward motion of the machine. The blocks settle into position across the prepared surface, creating a structured ground layer designed for load dispersion and surface stabilization. A leveling attachment replaces the initial cutting tool, smoothing and compacting the filled base before block placement continues. That switch between tools turns the same machine into both a shaping unit and a finishing unit without any change in direction. Once installed, the grid blocks can be filled with selected materials and compressed again for stability. The surface created through this method supports traffic load distribution, improves water drainage, and maintains surface integrity under repeated pressure cycles. Block placement can occur in single rows or parallel double lines, depending on the configuration path. Final passes align the surface, ensuring consistent block seating across the entire section before the machine advances to the next lane. A 747-8I aircraft requires coordinated ground handling forces to move its full-length fuselage during pushback operations. The nose gear begins rolling backward under tug control while the aircraft slowly aligns with the taxi path. Engine start sequence follows, introducing airflow buildup that stabilizes internal systems before taxi power increases. Hydraulic steering reacts to small corrections from ground coordination. No one expects something this large to move backward with such controlled direction while still silent at the engines. Fuel systems stabilize flow rates as auxiliary power transitions toward full engine support. A sudden thought hits. This scale of movement feels too coordinated for something this heavy to be unpowered. Once engines reach idle, airflow around the turbines begins shaping internal pressure balance for forward taxi readiness. Ground equipment disconnects and clears the aircraft's path. Taxi motion follows with slow alignment toward runway direction, keeping spacing consistent with surrounding traffic lanes. It feels strange watching something this large behave like it's waiting for permission to fully move. Final checks confirm system readiness before full taxi acceleration begins. The entire sequence connects pushback, startup, and taxi into one continuous ground handling flow. A loader-based demolition system operates inside marble quarry environments, applying controlled force to break and remove stone layers for material clearing. The machine positions its loader attachment against marble formations, then applies pressure to separate rock sections for excavation and site preparation. The first impact on the stone surface shifts the entire block faster than expected. This repetition allows uneven quarry sections to be converted into more manageable extraction fields. The machine then adjusts its arm height to match varying ground levels inside the quarry. This lets the loader reach higher and lower stone areas without stopping the workflow. The way it keeps touching different heights without breaking pace feels unusually consistent in motion. The system continues repeating the cycle across new marble sections, supporting ongoing quarry operations while reducing scattered waste. Material breaks away in layered fragments that fall directly into controlled piles beside the working path. Each pass of the loader reshapes the surface profile and clears obstructed zones. There is a noticeable shift in ground texture after each full sweep of the loader arm. The machine keeps repositioning itself slightly forward to extend its working reach across the quarry face. A short pause between movements gives a sense of the ground being re-evaluated before contact resumes. Loose fragments are pushed into more compact clusters for easier handling. The surface looks progressively less. The machine maintains alignment with the quarry slope while adjusting to changing elevations. A brief change in angle is enough to redirect large amounts of broken stone. Work zones expand outward as cleared areas open new access paths. The difference between untouched rock and processed ground becomes increasingly visible over time. Each cycle contributes to a wider reorganization of the quarry surface. The movement pattern feels like the terrain is being rewritten layer by layer,